This problem is dealing with torques that are unbalanced. We have a light string that's wrapped around a solid cylindrical spool with a radius of 0.075 meters and a mass of 0.5 kilograms. The 5 kilogram mass is then attached to the free end of the string, causing the string to unwind from the spool. We want to find out what is the angular acceleration of the spool. So let's write down our givens. We have, in this case, two objects, the spool and the mass itself. So we have the mass of the spool as a half a kilogram, and the radius of the spool is 0.075 meters. The mass of the object attached to the end of the string is 5 kilograms, and we want to find the angular acceleration. So as we go to our equations, what we see here is that the equation that we want to use is that the total torque is the moment of inertia times the angular acceleration. So we look for an equation with angular acceleration. The problem is that we neither have the torque nor do we have the moment of inertia necessary to solve at this point. So let's proceed and solve for this torque first, the moment of inertia second, and then the angular acceleration third. So when solving for the torque, what's causing this spool to rotate is the mass itself. So we go to our equation, our only other equation with torque, Fd sine of theta. And it's this gravitational force of this mass that's causing the rotation. So the force we want to use is the mass times the gravitational acceleration, or gravitational field constant, 9.81. And so we get 49.05 newtons. That's a little side thought there. So we have the torque is the gravitational force, 49.05 newtons, times our distance. Now the distance is from the point of rotation to where that force is applied. Notice that that distance is the radius. So our distance is 0.075 meters. And our angle, well, the angle we can see here is 90 degrees. So we've got the torque. Torque comes out to be 3.68 Newton meters. So we are partway there. But we also need the moment of inertia. Now a spool, a cylindrical spool, is going to be like a disc, and the moment of inertia of a disc is 1/2 mr squared. We're talking about a spool. So our mass, first we have the 1/2, and then our mass is 0.5 kilograms, and the radius is 0.075 meters. Don't forget to square that. So we get the moment of inertia to be 0.0014, and there's no special name for this unit, it's just a kilogram times a meter squared. And so now we have both pieces of information. We have 3.68 Newton meters equals 0.0014 kilograms times meter squared times our acceleration. And we get our acceleration, and it comes out to be 2,600 radians per second